Welcome to springlib.
We're told that a fence 8 feet tall runs parallel to a tall building at a distance of 4 feet from the building. We're asked what is the length of the shortest ladder that will reach from the ground over the fence to the wall of the building. Might help to draw a picture here. So we have, on the one hand, we have our wall of the building. Then on the other hand, we have our fence with a height of 8 feet. And we're going to lean a ladder against this. Now this is a distance of 4 feet from the wall, I should say. And we'll leave a ladder. It'll look something like this. And the ladder is going to have a length, let's just call it L. And this length can actually be broken up into two parts. I guess we'll call this L1 and little L2. Now the question is, there's also an angle that the ladder makes with the horizontal, which I'll call theta. So what are L1 and L2 in terms of theta? Well, we can transfer L theta up here as well. Now we know that L2 over 8, this is equal to cosecant of theta. And so solving for L2, we have L2 equals 8 cosecant theta. Now what is L1 in terms of theta? This is a little more difficult. So we have that L1 over 4, the distance between the fence and the wall, is equal to the secant of theta. So we have the L1 equals 4 secant of theta. And therefore the total length L as a function of theta is 4 secant of theta plus 8 cosecant of theta. Now to minimize L, we're going to take the derivative and find critical values. So we have L prime of theta. This is 4 times the derivative of secant theta, which is secant theta tangent theta, plus 8 times the derivative of cosecant theta, which is negative cosecant theta cotangent theta. So minus 8 cosecant theta cotangent theta. I will set this equal to 0. And so we have that secant theta times tangent theta equals 2 cosecant theta cotangent of theta. Let's write this in terms of sines and cosines if possible, maybe tangents. So I'll multiply both sides by, let's do sine and tangent. So I have this sine of theta times the tangent of theta times the secant of theta times the tangent of theta again equals 2. So this is the same as tangent cubed of theta equals 2. Therefore, tangent theta is 2 to the 1/3. And so theta is equal to the arctangent of cube root of 2, which is approximately 0.8999. And of course, this only makes sense because it's the only one within 0 pi over 2. Now we plug in theta. So we have that L of inverse tangent of the cube root of 2. This is 4 times the secant of the inverse tangent of cube root of 2 plus 8 times the cosecant of the inverse tangent of cube root of 2. And if you either plug this into your calculator, well, let's actually use triangles first. So we have a triangle here with angle inverse tangent of cube root of 2. So we have opposite side cube root of 2 and adjacent side 1. So our hypotenuse is the square root of 1 plus 2 to the 2/3. And so the secant, this is 4 times, this is 1 over the cosine. And so this is hypotenuse, square root of 1 plus 2 to the 3/2, or 2 to the 2/3, over adjacent 1, plus 8 times the cosecant of our angle. So this is 1 over the sine. This is a hypotenuse over opposite, or the square root of 1 plus 2 to the 2/3 over cube root of 2. And if you plug this into a calculator, it's approximately 16.65. And the unit is in feet.